considering the vehicle owner and the parking lot owner's preferences. And yeah.
Yeah.
But
all right, we have our time is up. There was also another question which I forwarded from the audience. So you can maybe Murali look at that during the next presentation and give some answer.
Yeah, sure. Yeah.
That, and we go forward. And the next presentation is called Towards a Domain-Specific Language for the Virtual Validation of Cloud-Native Mobility Services by Philipp Heisig. Philipp is a research associate at the IBIAL Institute of FH Dortmund and is proceeding with his PhD in the automotive domain, focusing on the simulation-driven validation of cloud-based mobility services. He also is interested in model-driven software development, cloud computing, and software product lines. He has been for years a part of different, especially ITR research projects such as Amalthea for public and Abstacle. And he's also active committer for Eclipse App for MC, as well as Eclipse Kuxa. This is also the third best paper nominee. So keep that in mind when you listen to presentation, please. So Philipp, you are.
Yes, thank you for the introduction. So you should hopefully see my screen now.
Yes, we do.
Okay, so the full screen, hopefully. Okay, yes, thank you. And my name is Philipp Heisig, and I wrote this paper together with Christoph, who did this research as part of his master's thesis. So let's start. So as you all know, connected vehicles are more and more on the road, and they can be fairly considered as IoT devices on wheels with high performance computation resources available. We have various sensors deployed, which delivers us high quality data stemming from radar, LiDAR, cameras, and so on. And vehicles getting more and more data-driven software architecture allow us to outsource services to the cloud also. And this is all based on a connectivity dimension. So we have connectivity among the vehicles, but which is more relevant for this paper, we have a connectivity to the internet and this to the cloud. With connected vehicle services, yeah, they are deployed within the cloud, and they operate in a safety critical and time sensitive environment with changing conditions. So when you design such a service working for a lot of vehicles and a variety of vehicles, you have to design it with some specific aspects in mind. So you have to design it with connectivity in mind, with security for sure, but also with scalability and reliability. And for example, you could use a microservice architecture to foster scalability. And also you have to have in mind that you have to process a lot of multimodal mass data stemming from the sensors, but also from other data sources. And we're talking about distributed systems with various components. So we have our embedded system within the vehicle, but on the other hand, we have also our cloud services running in the cloud and using high performance computation resources from the cloud. And in between, we may have additional infrastructure like a roadside unit also. When it comes to testing these services, we also have to consider different aspects, like we have to consider network conditions, like latency and bandwidth. We have different network protocols involved in infrastructure. Again, we have to test security, scalability, reliability, and which makes it really challenging is the vast number of potential traffic situations we have to consider. So there are different testing strategies if you want to test your cloud-based connected vehicle service. So occasional applied testing approaches within the automotive domain focus more on the vehicle. So you want to verify in-vehicle functionality. But now we have services operating upon networks of different vehicles and infrastructure. So we need to sync or resync our testing strategy. So one could argue that we can use dummy data. This would allow us maybe to test the scalability of our service, but we neglect some environmental conditions, and also the semantics of the data is not sufficient maybe to validate our functionality. Another approach would be maybe to use a vehicle fleet, using data from vehicle fleets, or you use hardware and vehicle nodes to generate massive data. So vehicle fleets would probably provide the best or most realistic data you could have for testing, but for obvious reasons, it's not feasible from economical and operational constraints. So you would have a really large vehicle fleet driving around and delivering the data. So what is more and more used in this context are simulations. So simulations are around for a long time, as they are really cost efficient, and yeah, they can be carried out through the whole development process, allows us to give us feedback already in early stages of the development process. With simulations, we can test a lot of different traffic scenarios. So by just varying some parameters, simulations have also the advantage, we can run it in the cloud, so we can run a lot of simulations at the same time. And when we are thinking about connected vehicles scenarios, we have to think about that we need a traffic simulation, but you also need to consider other simulators to be coupled. So you may want to have a network simulator, but you also may need a simulator for your infrastructure, or a simulator for in-vehicle application, delivering the data to the cloud service. So testing this connected vehicle services is somehow challenging, and requires some work to set up such a test environment, especially when you have a coastal emission environment. So it can be really complex and time consuming to set something up. And this is especially true if you're like a service provider, like an insurance, who want to come into this domain and offer your services, but you may don't have the expertise to set up such a test environment. So this is where our paper set on. And so our idea was to have a model-based description for testing this connected vehicle scenarios. This is part of a process. You can have a look at the paper. So there are more steps involved, but the basis would be to describe your scenario or the requirements for your scenario via a model-based language or a domain-specific language, to have models involved, so you can formalize them and so on. So a lot of research is ongoing regarding simulations for autonomous driving, but our focus was merely on the cloud side. So we want to test our software architectures defined for our connected vehicle services and the functionality within the service. And therefore, we came up with the first prototype of a domain-specific language. Our goal was to describe basic road networks, traffic demand, the connectivity dimension, and also additional properties relevant for testing. And based on this description, the goal is to generate a simulation environment which allows you to test your service then for different scenarios. So we started with some frameworks, available frameworks to have a look at. So we used SUMO for our traffic simulation part, because SUMO is really well known in research community, is open source, and have also real world scenarios available and is controllable. So it was perfectly fitting in for our purpose. And then we also have a look at Eclipse MOSAIC for realizing the co-simulation environment. So MOSAIC is a really nice framework for realizing such an co-simulation environment. It integrates really nicely with SUMO and provides additional features like integrated simulators, application simulation, and it's also open source. So we use that. And for realizing our domain-specific language, we fall back to XText, as it's also open source. It's really well-known and has a really good editor support also. So how does our DSL looks like? I don't show you the DSL. I just show you an example. Due to lack of time, you can have a look at the paper for the DSL. But so I give you a small impression how the DSL looks like. So main building block or foundation is this configure block. So it's used to configure the single simulators you want to use. For example, here we have SUMO, where you can either reuse an existing scenario or you can generate a random scenario. Therefore, we provided some properties like the size or the routing algorithm and so on. In addition, what is also interesting to mention is our mode. So you have different modes available for the generator. So for example, if I choose the mode MOSAIC, the generator not only generates the traffic scenario for SUMO, for example, but it also generates additional files necessary to run this scenario within SUMO, like there's a runtime JSON needed and so on, a scenario database. And this is done based on this mode. Another mode would be a Docker. So you can also have the option to generate a Docker image, which is really easy then to deploy. I give you a small demo or impression of how the DSL looks like. So most of you probably have seen a XText DSL. So this is how you can use the DSL within the editor. So in this way, we just define a really simple SUMO scenario, which is generated, and you can directly start it. So just as a small impression. And for our paper, we defined, or to test our first version of the prototype, we defined a small use case of a restricted traffic zone. So basically this use case prevents vehicles from entering a geographical predefined area. This is monitored by a local roadside unit, which communicates with the vehicles and with the cloud service. And the cloud service processes the data and determine if the vehicles are allowed to enter. And if not, a stop signal is sent to the vehicle via the roadside unit. So here's the architecture. So we have different simulators for this use case. We have a traffic simulation via SUMO. And then this is running within the MOSAIC runtime, and we're using the application and simple network simulator from MOSAIC for realizing this in-vehicle application and the communication between vehicles and the cloud. So this is how the architecture looks like. And I will show you now how the configuration would look like for our DSL. So for simplicity, we just reused an existing scenario. It's this highway scenario with some parameters. And we choose the mode MOSAIC to generate additional files necessary to run this scenario within MOSAIC. So as a disclaimer, we had to do some manual tweaks still. What you have always to do, you have to implement your in-vehicle application. And we have to set some parameters for the network simulator by hand. So our DSL already generates all the files necessary for doing this. And I will show you now how it looks like when we run this scenario. So you see there are a lot of vehicles spawned at the highway, and there's a roadside unit communicating with this vehicle and stopping them. So it's just a dummy example. It wouldn't make sense to do this actually on a highway. Would be really dangerous. But for testing our service or for testing the first version of our service, it was sufficient to give us some feedback and data. Okay, so let's conclude. So with our prototype, we are able to describe minimal traffic scenarios already for testing this connected vehicle services. We was able to generate this coastal emission environment via MOSAIC. and our editor has some good usability and also Docker support, which is really nice. However, there are still some drawbacks as we are in an early phase. So we have our DSL was a little narrowed down to Sumo. So we have the structure looks a little bit like a Sumo configuration file. So we need to find a way to describe it in more general purpose way. And also running the Sumo scenarios within Mosaic has some minor limitations yet, but I think this will be fixed in the future. And also what is always with DSLs, you have to balance the functionality and complexity of the language. So if you want to cover the whole domain, the language probably gets way too complicated. Otherwise, if it's too simple, you won't cover enough test cases. So this is always a thing to balance the DSL. For the future work, we want to consider more open standards and formats like open scenario or the vehicle signal specification Sebastian showed us earlier this morning. And furthermore, we want to provide a web-based user interface for DSL and enhance it with new building blocks. And what is also the most important thing is to define metrics to assess the architecture of our services against non-functional requirements. This could be, for example, to measure microservice anti-patterns, such as API versioning or hard-coded endpoints, or you can check for cyclic dependencies. Okay, thanks for the attention, and I'm happy to answer questions.
Yeah, we have some minutes. There's already one in the chat by Juha-Pekka Tolvanen. So how you see the idea of using non-textual DSL that maps closer to the problem domain, for instance, map-based graphical?
Yeah, that's always a good question when talking about domain-specific language. To be honest, I prefer mostly textual DSLs as I have some more flexibility, and we probably have to cover a lot of different properties for scenarios. And I think for this use case, it's easier to have it in a textual way. But yeah, so a graphical representation is always helpful also. So this would be maybe an idea to abstract or provide some graphical notation to abstract another level of complexity. And but that's why we also want to provide this web-based interface. So users just can enter via the browser, the DSL. And so it's, for the first prototype, it's easier to have textual DSL instead of graphical notations. But this would be something we definitely will consider for the future also. So maybe what could be also done is like you're using OpenStreetMap to get your scenario or define the area of your scenario, and then you use a textual DSL on top to describe some additional properties.
Thank you. Do we have other questions? We have time for one quick one.
I think there's one question.
Yeah, have you considered collaborative editors?
Not yet, but this is also something, especially when developing cloud services or microservice architecture, you're working like within small teams, but you have to collaborate with other teams. So it would be definitely something worth to investigate for having these collaborations among different teams, for example.
Yeah, there's a comment also that there are already existing collaborative editors available. Okay, but thank you so much, Philipp, for the presentation. It was very interesting, and I guess it's time to move forward in the